it is time to start implementing our server. The first thing that we have to do is to create a new project. As we remember, we do that using the cargo new command. We have to pass a name for our project. In this case, we're building an HTTP server. We'll just name it server. Cargo will go ahead and create our new project. We can go to the folder. We can just run it to make sure that everything works. We see that it compiles, it prints hello world. Everything is fine, so we can actually open it in Visual Studio Code. Okay, let's move that to a different workspace and let's explore what we have inside. As expected, we have only a single main.rs file that has our main function and prints hello world to the screen. So far so good. Now let's start implementing our server. First, let's imagine how we would like to use the server. What interface do we want to provide? Let's assume that we'll create a variable called server and we will assign a new instance of our server to it. We remember that we were creating new instances of a string, calling the new function on it. So let's write something similar here. We can say server :new. Okay. This seems fine so far. And after that, we will just want to, let's say, call a run method on our server. Okay, this run method will probably never return. It will loop forever, waiting for new connections on some TCP socket. Another thing that we have to do is actually pass an IP and a port to our server so it knows exactly where these network connections will be coming. We can just pass a string literal here. So in Rust, to pass a string literal, you just use the double quotes. And in here, we can type the IP that we want. We want our server to listen on localhost, and let's say that we'll use port 8080. Okay, this is how we would like to use our server. Now, let's actually implement that. Server here is a struct. A struct in Rust is a custom data type that lets you group together related data, kinda like a class in object-oriented languages. Let's see how we create structs. To do that, we use the struct keyword followed by the name of the struct that we want. In this case, we want our struct to be called server. Then we just open a new block with curly brackets, and in here we put the data that we want our struct to hold. In our case, we have a single string that holds the IP and the port for the struct. So let's name our field address and give it a type of string. See that this syntax is very similar to the syntax that we use for defining functions and giving types to parameters for functions. The values of a struct will be placed next to each other in memory, but we can't assume any particular memory layout because the compiler might move things around. Okay, we have our struct. It holds all the data that we need at the moment, which is just the address. Now we need to actually add some functionality. To add functionality to a struct, we can write an implementation block. So unlike other languages that have classes and the classes contain the data and all the functionality in one place, in Rust we have one block that holds the data, which is the struct definition, and then we have an implementation block for this struct that holds all the actual functionality. To create an implementation block, we use the impo keyword, and again we just use the name of our struct and we open a new block. So in here we can write all the functionality that we need. There are two types of functionality that we can associate with a struct. It's either a method or an associated function. Let's talk about methods first. Methods are very similar to normal functions, but they are defined in the context of a struct. Very similar to the methods on objects in languages like Java and C++. Methods in Rust always take a special first parameter called self. Self represents the instance of the struct the method is being called on. The other type is associated functions. These are functions that are associated with the struct type, hence the name, but they don't need an instance of the struct, similar to static functions in other languages. In our case, new is not a method. New is an associated function because we call it directly on the struct type, not on an instance of it. We use the double colon syntax to access associated functions. Let's implement that. In our implementation block, we can write a function. The syntax to write an associated function is exactly the same as for writing normal functions. We use the fn keyword, in our case new, and this is our function. We see that our function accepts a string. Let's call this again address, and it is of type string. And it will return a new instance of our server. So it will return a server. Okay, this is great. We can see that the compiler complains because it wants a server, but it actually didn't find any return type from this function. Okay, to actually create a new instance of our server and return it, we can just type the name of the struct followed by curly brackets, and in here we can pass all the data that the struct needs to hold. In our case, our struct only needs to hold the address, which is a string. We already have that, so we can just type the key address and pass the value address to it. All right, we see that the function compiles. The compiler doesn't complain. Neat trick that we can do here is that if the name of the field in the struct is the same as a variable that we have when we're creating it, we can omit this assignment and we can just pass the variable, and the compiler will figure out that this is also the name for the field. So this makes our code a bit nicer. All right, we have our constructor for our struct. We see that it's called new, but the new name has nothing special about it. We can call this whatever we would like. It is just accepted that the main constructor for a struct is called new. We will be following this good practice throughout our code. Now let's implement our run method. To implement a method, the syntax is again exactly the same as for a normal function or an associated function. We have our methods, but as we said, the special thing about methods is that they accept a special first parameter called self. And self just points to the instance of the struct. So if we want to read fields from the struct, we'll do it through self. In languages like Java and C++, this is called this, but Rust uses the self keyword. So self follows the ownership rules for normal variables. In the case here, the run function takes ownership of the entire struct because it takes ownership of the self variable that points to the struct. So the struct will actually be deallocated when the run function exits. If we don't want to deallocate our structure at the end of our function, we can make self a reference. So in this case, self does not take, run does not take ownership of the struct, and it can also be a mutable reference. So it follows the exact same rules as for everything else. For our use case, we can just let run take ownership of the struct because we just want to call run and then run will loop forever. So we will not be using our struct outside of the run function anyway. One last thing that we can do here is swap the server type here with the self keyword like this. In every struct, there is a special type called uppercase self, which is an alias for the name of the struct. In this case, self and server are interchangeable, but in our code, we will write the self type instead of the name of the struct. So here we can swap the name of the struct with self. And yeah, we create a new self and we return a new self. But everything will still work fine. Okay, the last thing that we have to do now is to actually try and compile our code. So if we run cargo build, we see that our code does not compile. The reason for this is that we expect a struct. So we know that the new function expects a string, but it actually found something else. It found a lowercase str, or a reference to a lowercase str. So again, we're expecting an uppercase string, but the type that we got is a lowercase str. That's interesting. In the next video, we will explore this error further.